In this video, we will show a typical workflow in the Materialise Mimics Innovation Suite, going from segmented medical images to a model that is pre-processed for finite element analysis. You will learn how to mesh a 3D model in 3-matic and assign its material properties in Mimics. Open the femur project in Materialise Mimics from the demo files folder of 3-matic. Copy the 3D object called Yellow2 by right-clicking on its name in the list. Then open 3-matic and press Ctrl-V to paste the Yellow2 part from Mimics in 3-matic. Rename the object to femur and change the color to that of a bone by opening the Properties page of the object. On this Properties page you can also find information about the number of triangles and nodes of the object. To visualize the bone surface mesh, we can change the view from smooth shaded to filled with triangle edges, either in the left toolbar or with the shortcut Shift plus F3. Now the amount of detail in the femur needs to be reduced such that less elements are used to represent the shape. This will speed up the FEA simulation. You can do this by using the Smooth tool, which is located in the Fix tab. An alternative tool is the Wrap tool from the Fix tab. We will use the Uniform Remesh tool to optimize the quality of the surface elements. This tool can be found in the Remesh menu. Set target triangle edge length to 1.5 mm. Estimations on the number of triangles that will be generated and the memory usage are shown in the log panel. You can see that the mesh is more uniform. The next step is to create a volume mesh with the Create Volume Mesh tool. To get a uniform mesh inside the model, a maximum edge length needs to be set. For this exercise, use TED4 elements with a maximum edge length of 3 mm. Take into account that the maximum edge length will have an influence on the number of elements, which in turn has an effect on the calculation time in the solver program. After applying the operation, a volume mesh is created. Clip the part to have a look at the volume elements. This can be done by using the standard section Y as a clipping plane. Change the slider position to place it in the middle of the femur. Now we can see that the element size is uniform all over the model. Next, an accurate material assignment can be performed in Mimics by combining the information of the DICOM images and the volume mesh. First, we need to copy our object back into Mimics by selecting the object and pressing Ctrl-C to copy it, and then paste it by pressing Ctrl-V in the Mimics femur project. The volume mesh will appear in the FEA Mesh tab of the Project Management panel on the right-hand side. Open the Materials tool from the toolbar at the bottom of the FEA Mesh tab. Choose a gray value-based method to assign the materials. Create two material types. For the first material type, we will define a density of 50 kg per cubic meter, which will be used for all negative Hounsfield unit values and all values up to 100. The purpose of this material type is to set a lower limit for the density, which helps to prevent negative density values. For Young's modulus, fill in 0.004 times rho squared 2.01, and for the Poisson coefficient, fill in 0.3. For the second material type, 10 materials will be used to cover the trabecular bone and cortical bone. Take 50 kg per cubic meter and 1900 kg per cubic meter as the minimum and maximum density values of the bone. For Young's modulus and Poisson coefficient, the same values as for material type 1 can be used. Then press Apply and close the window. To inspect the inside of your model, use the clipping functionality that is located on the toolbar of the 3D view. In the Clipping tab on the Project Management panel, check the coronal clipping option and choose None for texturing to see the result. Now we can export the mesh with material properties to a solver program. Go to the Export menu in the File menu and choose which solver program you want to export your mesh to.